39 is the second part of 5.2. We need to talk about that box that talks about in behavior polynomial functions, okay? So we are going to start classifying polynomial functions, and we're going to have to start using this box. So here's the deal. If you put this on a separate piece of paper, I will let you use it on the quiz to tell me some things and on the test that we take, okay? Because you need to be able to look at graphs and tell me what type of degree it is. What? No, it doesn't have to be. What type of leading coefficient it is, and I need to know what's happening to the ends. So, as you can see, there are 4 different ones happening, right? Like this. One goes, and it kind of looks like an N, yes? Like this. Okay? If my graph looks like an N, okay? That's the best way I can describe it. That means that the degree is odd, okay? What does the degree mean? Where do I find the degree on a function? What is a degree on a function?
It's isn't it number?
What number?
X.
Yeah, it's the highest exponent. So if my highest exponent is an odd number, okay, my graph could possibly look like this. We're going to talk about what else has to happen. Your leading coefficient, okay, your leading coefficient has to be a positive number. Okay, so if your degree is odd and your leading coefficient is positive, your graph's going to look like an N. Odd power, leading coefficient is an even number. Okay, what that means is as f of x, okay, as f of x approaches the positive side, it's going to continue to become positive. So as I plug in an x from this side, it becomes positive. Okay.
Wait, what?
As x gets plugged in, it becomes positive. So as I plug in a number to x, it's going to be a positive. So if I plug in a positive x, I'm going to continue on to positive infinity. Okay. Over on this side, what's happening is as I plug in an x, I'm going into negative infinity. So f of x yields negative infinity as x becomes negative, towards negative infinity. So as I plug in a negative x, I get negatives. As I plug in positives, I get positives. Okay? If my leading coefficient is positive and my degree is odd. Okay? You're going to have the reverse of that, okay, a graph that looks like this, when your degree is what? What do you think your degree has to be if it's the reverse of this?
Positive.
Oh, okay, that's where this is.
Well, not positive. It would be
the coefficient is negative.
Right, the coefficient is going to be negative. The degree is going to stay the same. So if the degree is odd, I'm going to have an N thing or a backwards looking N, okay? So if I have odd degrees, I have figures that look like N's, okay?
I switched my wording.
No, you're fine. You're fine. And your leading coefficient is going to change, though, here, okay? So now my leading coefficient is going to be negative, okay? When it's backwards, when it's flipped, which means this. As I plug in, as f of x approaches infinity, as f of x approaches negative infinity, okay, that happens as x approaches a positive infinity. So what it's saying is, when I put in positive x's on this side, I'm getting negatives out. Okay, putting positives in, I'm getting negatives out. Which means on this side of my graph, as I put in, okay, yeah, I'm going to get positives out as x becomes closer to negative infinity, okay? So when I put negatives in, I'm going to get positives out on this side. So it's the reverse of this one, okay? Then you have shapes that look like W's and M's is what I say. Okay? So you are going to have a shape that looks like this. Something along those lines. Okay? This is when your degree is even. And what do you think my leading coefficient is going to be on this one? Yes, and here's why. Okay, so my leading coefficient is positive on this because look at these. When I am going positive, I'm going up on both of these, right? Okay, so my positive coefficient means that I have a positive graph. So this is f of x yields positive infinity, okay, again, as x approaches positive infinity. So as I put in positive x's, I get positives out, okay? So over here, it's the same thing. F of x approaches, okay, this one, is it positive or negative? Is it becoming positive as I put in negatives, or is it becoming negative as I put in negatives?
It's becoming positive.
It's becoming positive. So this one still says f of x approaches positive as x becomes negative. Okay? So on these graphs, I have both positive outcomes no matter if I have a negative input or a positive input. Okay? Because the power is even. Think about this. If I have negative 3 squared, what type of number do you get out?
Positive.
A positive. If I have negative 3 to the 4th, what type of number do I get out?
Positive.
Positive. That's why if my degree is even, I'm going to get positive outputs on both. Okay? Does that make sense? Okay. Now, if it reverses, it kind of looks like, this should be more round. It kind of looks like an M. Okay? Your degree is still even. Okay? But your leading coefficient is what now?
Negative.
Yes. Okay, so this changes what way my graph goes because, let's take a look and I'll tell you. Give me 1 second. Okay. My leading coefficient is negative. Over here, it would look something like this. It would say x squared, right? Which is 3 squared, okay? Or it would say x squared, which is like this. So this one is going to say something with a negative leading coefficient. If your coefficient is negative, that means it's going to flip my graph. Yes, we talked about that with quadratic functions. Okay. So, as I approach, okay, what happens here? Do I get negative or positive outputs as I put in positive x's?
You still get positive. Well, you know you're negative.
I get negative because it's facing down. So I get negative outputs as x becomes positive inputs, okay? Over here, what happens? As I put in negative inputs, what happens to my output? F of x becomes closer to negative. When I put in negative inputs, what happens to my output? Do I get negative or positive outputs? Negative. So f of x becomes closer to negative infinity as x approaches negative infinity. Okay? So we need to be familiar with this chart because we're going to have to look at graphs. Well, not at graphs. Some at graphs. We're going to have to look at problems and be able to decide what type of graph I'm graphing. Okay? So I'm going to look at a problem and I'm going to say, ooh, this should look like a reverse N, or this should look like an M, because then it gives me an idea of what I'm trying to graph so that I can make a rough sketch of it and know if I'm onto the right solution. Now, okay, let's say, look at example 4. It says, what is true about the degree and leading coefficient of the polynomial function whose graph is shown? So look at that graph right there under example 4. What do you know about that? What do you know about the degree and the leading coefficient of that function?
Degree is even and the leading coefficient is negative.
Yes, because it's facing down and because I have a shape that looks like an M, so I have like 3 or 4 turning points there. So it would be D. Degree is even, leading coefficient is negative. Okay. Look at under there, the guided practice, okay? Do you see that function right there? That graph over there?
Yes.
What type of leading coefficient does that have?
It's a negative and the degree is odd.
Good. It has a negative and the degree is odd. Beautiful. Okay. Now, the last thing that we have to do with this is that we have to be able to sketch graphs of these things. Okay. So let's say that it tells us to graph. And it gives us f of x equals negative x cubed plus x squared plus 3x minus 3.
No, do these guys like have to like be perfect, or they can kind of go into something similar to like?
Well, we're going to make these perfect in a way, and I'm going to tell you how. Okay? First of all, what type of things should we get? What type of image? My power is what?
Your power is odd.
Odd, and my leading coefficient is?
Negative.
So I should get
That's.
that like backwards looking in thing, yes? Okay. The way you graph these, and there's no way around it, is you simply plug in negative and positive numbers. Okay, we're going to make a number chart. My suggestion is this. I would plug in negative 3, negative 2, negative 1, 0, 1, 2, and 3, so that we get a good look as to what is happening. Okay?
So you just use those,
And then we graph
those
each
numbers.
one, or?
And then we graph each one, and we play connect the dots.
Can you just use those numbers all the time?
You can use those numbers all the time, Cole. Yes.
So it doesn't have to be specific. Doesn't have to be specific numbers. You can just.
Correct. So let's plug these in. If I take this and plug it in, okay, it would look something like this. I'm going to just make it over here, and then we can switch the numbers around each time. How's that sound? Plus 3, negative 3, plus 3 times negative 3. Okay. What is negative 3 cubed?
Negative 27.
And what's negative 27 times negative 1?
27.
Great. So I have 27. What's negative 3 squared?
9.
What's negative 3 times 3?
Negative 9.
Negative 9, and then I have negative 3. So these cancel, right?
Yes.
And then what's 27 minus 3?
24.
So I get this. Okay.
Oh.
Now, let's plug in negative 2, yeah? Okay. So let's plug in negative 2 and see what what happens. Now, like I said, this takes time, but it's not hard. What's negative 2 cubed?
Negative 8.
And negative 8 times negative 1.
8.
And negative 2 squared.
Negative 4.
Positive 4. 3 times negative 2.
Negative 6.
And negative 3. So I have negative 9 here, right?
Yes.
Plus 8 gives me negative 1. Plus 4 gives me positive 3. Okay. Now, let's plug in negative 1. Negative 1 cubed. Negative 1 times negative 1 is 1. Negative 1 squared.
1.
3 times negative 1.
Negative 3.
And then negative 3. So negative 6 plus 2 is... Okay. What happens when I plug in a 0?
Just say 0.
No.
Oh, well, no, it'd be
0, 0, 0.
Negative 3.
Negative 3. What happens when I plug in a 1? 1 cubed
1.
times negative 1.
Negative
1 squared.
1.
3 times 1.
3.
And negative 3. So what happens?
That cancels to 0.
Good. Okay. Plug in a 2. 2 cubed.
8.
So 8 times negative 1.
Negative 8.
2 squared.
4.
3 times 2.
6.
And negative 3. So I have 6 and 4 is 10, right? Minus 8 is positive 2, and then 2 minus 3 is... Oh, okay. So, there is room for error here if we don't multiply and add right. What's 3 cubed?
27.
Times negative gives me
Negative 27.
3 squared.
9.
3 times 3,
6.
and then minus 3. So I have 18 here, right?
Yes.
What's negative 27, 28, 29, 30? What's negative 30 plus 18?
12.
Negative.
Negative 12.
Okay, so now I'm gonna, on yours, you're gonna number things better than I am, but I'm just gonna plot these and make the picture, okay? So that we get a gist. So if I say 1, 2, 3, 1, 2, 3, negative 3, positive 24 is someplace way up here, okay? Negative 2, 3 is someplace way down here, right? Negative 1, negative 4 should be someplace down here, right? 0, negative 3 should be a turning point. Okay, 1, 0. Then I have 2, negative 1, right? And then I have 3, negative 12.
So it's.
So my shape, does it look like it's supposed to?
Yes.
Yeah. So
Yes.
So it doesn't have to be.
So on your graph, you don't have to graph it perfectly as long as I have this chart.
That
So
seems easy
on the
enough.
quiz, would you look for mainly for the
Charts,
tables,
right?
right?
Yes. So if the table's right and then you make a rough sketch of it, I'm good to go. Okay? So that's what that looks like. Let's take a look at one more and then we'll be done. Let's say you have that I want you to graph f of x equals x to the 4th and then minus x cubed minus 4x squared and then plus 4, okay? Once again, I need charts on all of these, okay? So we're going to do negative 3, negative 2, negative 1, 0, 1, 2, 3 again, okay? And I would like a good range of numbers like that, like three negatives, 3 positives, and 0, okay? We're going to plug in over here again, so I'm going to say negative 3 to the 4th minus negative 3 cubed minus 4 times negative 3 squared plus 4. What's negative 3 to the 4th? Well, first of all, what type of graph should I get?
W.
A W? A W shape-ish thing? Okay, yes, because my leading coefficient is positive and my degree is even. So yes, a W-ish thing. Okay, what's negative 3 to the 4th? It's negative 3 to the 4th.
$81.
81. What's negative 3 cubed?
27.
Negative 27 times negative 1 gives me positive 27. What's negative 3 squared times negative 4?
Negative 36.
Yes. Yes, you're right. I
Negative
wasn't
36,
thinking. And then and then plus 4, right? So we need to add and subtract all these. 81 plus 27 minus 36 plus 4 gives you,
76.
beautiful. Now do you see why I say you don't have to graph it accurately all the time,
Yes.
as long as your chart is correct? Because you're going to get some very large
Yeah, so
numbers.
if this was on the quiz, you wouldn't grade us for
I would want you to graph the sketch of it, like make it a rough sketch, like I'll do here at the end, but I need these numbers to be right. Okay? What is...
So if you don't graph it, like if we don't
So
graph
doesn't
it all
have
the way
to-
to like
so it doesn't have,
76.
it doesn't have to be drawn.
You're going to graph it like I graphed this one over here. I
Yeah,
graphed
we
the
just have to
X and
graph it
Y's,
accurately,
and then I
yes.
just, or the X's perfectly, and then I...
It doesn't have to be drawn.
Right.
Yeah.
Okay, what's negative 2 to the 4th?
It's about 16.
Okay, and what's negative 2 cubed?
8.
Negative 8.
Negative
And then negative 8 times negative is positive 8. What's negative 2 squared?
4.
And 4 times negative 4?
Negative 16.
And then plus 4. So now I just have 8 plus 4, right?
Yes.
12.
Yes.
C.
Now we do negative 1, right?
Mm-hmm.
Okay. What is negative 1 to the 4th? 1. What is negative 1 cubed?
Negative 1.
Times negative is
1.
negative 1 squared
1.
times negative 4.
Negative 4.
And then plus 4. So I end up getting
2.
2. If I plug in a 0, what do you automatically get?
4.
Yes, 4. Beautiful. Now plug in a 1. 1 to the 4th.
1.
1 cubed.
1.
Times negative. 1 squared times negative 4.
Negative 4.
And then 4, what happens?
So that's 0.
Beautiful. Okay. 2.
So, I have a question.
Yes.
For all these, will 1 always have 0 next to it?
Not
Is that- okay.
necessarily. What's 2 to the 4th?
16.
16. What's 2 cubed?
8.
Minus.
Negative.
And then 2 squared.
4.
4 times negative 4.
Negative 16.
And then plus 4. So this cancels, this cancels. This gives me negative 4, right? And then we're going to do 3, and then we'll be done. Okay. What's 3 to the 4th?
81.
Yeah.
Yep, because it's 9 times 9, right? And then what's 3 cubed?
20.
So I get negative 27. 3 squared is 9. 9 times negative 4 is,
Negative 36.
and then plus 4. So let's add and subtract all these. 81 minus 27 minus 36 plus 4 should give me 22. Yes?
Yes.
Okay. Now, here's what you would do. I'm going to go negative 3, positive 3. Negative 3 is 76, right? Way, way up there. Negative 2 is 12, so something like here. Negative 1 is 2. It's going to be really low on this graph. 0 is 4, right? Okay. 1 is 0. 2 is negative 4. And 3 is positive 22, right?
Yes.
So this graph should look something like this. Do you see how it's a W, but it's a weird W, yes? Okay. Those are the things you're doing on your homework tonight.
So if you put in a 1, it won't always equal 0.
It depends, really.
Like, would it most of the time?
A lot of times it's going to, but I can't guarantee that that is a yes